So if we're asked to add the first 15 terms of a sequence like this, we're going to need a little bit more information about the formula I could use than we already have. So this is not an arithmetic sequence. This appears to be geometric, and if I write out its formula, it's going to look like this. And that's because our first term is 2, and our common ratio is 3. So that's the form we would use to find if we needed the 15th term, for example. But that's not going to add together the first 15 terms. That's just going to find for us an individual term that we need. So it's no longer true, if we're referring back to the arithmetic series formula, that I can just add certain terms together from this sequence and keep getting the same result. So we need to do some more work to find a new formula that's going to allow us to get here. So what we're going to be doing is using some general representations of a geometric sequence to give us our formula, and then we'll apply it to this series that we have here. So let's say that we have just a basic geometric series that looks like this. We've got our first term, we've got a common ratio, and we raise it to the n minus 1 power. That's some sequence. And then I turn that into a series, meaning I want to add together the first n terms of that sequence. So what will those first n terms be? Well, the first term is going to be f1, right? And then the second term is going to be f1 times r. And then the third term is going to be that first term times r, and so on. All the way until we are finally adding together that first term times r to the n minus 1 power. And that would be the final term of our sequence, because when I plug in n to this formula, I do have n minus 1 as my exponent there. So that would be the final term. And this is what we're adding together here, just without the actual numbers. We're more just representing it in terms of variables. Okay, so there's some work that we can do with this to eventually get ourselves a formula that's a little nicer for actually calculating this. So one thing that we can do to this formula is I can multiply it by r. So just to save this right now, I'm just going to take a copy of it and put it off to the side, just so that we've got that when we need it, and save it there. So what I'm going to do now is I'm going to multiply this whole thing by r. And if I multiply the left side of this equation by r, then that means I have to multiply the whole right side of this equation by r as well. So what's that going to leave me with? Well, I'm going to have r times the series of the first n terms, and then I'm going to have f1 times r for my first term, because that's this times r. But I also have to do this times r, right? Because this r is getting distributed in here to each individual term. So now I'm going to have f1 times r squared. And then this third term is now f1 times r to the third. And so on. This continues until finally my last term is no longer f1 times r to the n minus 1. It's times r to the n. Because if I multiply r to the n minus 1 by r, then I get r to the n. Okay, so this is another sort of complicated looking statement. It sort of seems like, why did we even multiply by this r? Well, it's just a process of getting us this series formula that we're looking for. So now what we can do, because I have this statement down here that says what s of n is, and I have this statement here that shows us what r times s of n is, I can subtract these two things, and you'll see that something interesting happens with that subtraction. So I'm going to give myself some space here, and I'm going to actually do the subtraction. I'm going to take the series of the first n terms and subtract r times the series of the first n terms. But I'm not going to write it out side to side. I'm going to stack them by combining like terms. So first I've got the series of the first n terms, which is this expression right here. So I can put that there. Okay. So that's that. And I'm subtracting minus r times the series of the first n terms. And so what I want to do when I do the subtraction is line it up so that I've got my like terms. So see, if I put it like this, then this is going to be some weird subtraction. But I could slide these over, and that subtraction is not actually going to be so bad. So by stacking them by their like terms, I can subtract terms a little bit easier. And so I'm going to leave that there. And I'm just going to make this look a little nicer real quick. All right, so now I'm going to do the subtraction, and when I do that, I'm going to do it by subtracting like terms. So I've got f sub 1, or my first term, minus nothing. All right, f sub 1 minus itself is just going to be itself. But with these other terms, something really nice is going to happen. When I subtract f sub 1 times r minus f sub 1 times r, those will cancel because those are the same exact thing. So when I subtract, those will disappear. Same thing's going to happen with these next two terms. And these dots are showing that this pattern continues. The next one after this would be f sub 1 times r cubed, which is this term. And this pattern of everything canceling itself out would continue over and over and over again until finally f sub 1 times r to the n minus 1 would cancel with the term that comes right before this one. And the only thing that we'd be left with that wouldn't cancel would be that term there. But don't forget that it's 0 minus that term. So we're left with negative f sub 1 times r to the n power. And that's everything that results from doing that subtraction. So we're just going to condense this really quickly and show the way that it looks now. So on both sides of the equation, I've got the series of the first n terms minus r times the series of the first n terms equals, and all that's left over here is f sub 1 minus f sub 1 times r to the n. And remember that the whole point of this is to get a formula for the series of the first n terms. We're trying to find a better way to write this. So I want to get that alone in my formula here. So what I'm going to do on the left side is factor that s sub n out, the series of the first n terms, and that's going to leave me with 1 minus r. My right side looks the same. And then to get the s sub n alone, I'm just going to divide by 1 minus r on both sides. So I have f sub 1 minus f sub 1 times r to the n over 1 minus r. And now I have that s sub n alone, and so let's just think about what this means for a second. This means that if I want to add the first n terms of a geometric sequence, of a sequence that behaves like this, then I can take the first term of that sequence and subtract from it the first term of that sequence times the common ratio to the n power, n being the number of terms I'm adding, divided by 1 minus the common ratio. And so if we want to continue to use a, you can do that, right? You'll see this formula written probably more commonly as s sub n equals a minus a times r to the n all over 1 minus r. It's another way to write this. Rather than using f, they're using a there. But the idea is that we can now use this formula to help us add together the first n terms of any sequence. So let's bring that formula with us back to the example that we were asked at the very beginning to find a solution to. We want the first 15 terms of that a sub n sequence. So we can do that here. And we'll say that the series of the first 15 terms of this sequence is going to be a sub 1 minus a sub 1 times the common ratio to the n power over 1 minus the common ratio. So what are these values? Well, the first term in the sequence is 2, so that's 2 times, and our common ratio here is 3. We figured that out initially. N in this case is 15, because that's how many terms we're adding together. And then this is going to be 1 minus the common ratio, which is 3. And if you put that into a calculator, you'll end up with 14,348,906. And you could check that again using a summation if you wanted to. Feel free to do that. And that's not a bad way to check your work if you're asked to do this on an exam or a quiz in the future as well. All right, so this is another formula that you're going to be asked to use. Make sure that you've got this formula in either form here circled and saved in your notes, ready to use tomorrow.